Okay, now we're going to talk a little bit about power. So what I'm going to do now is I'm going to kind of run through another example. We're going to kind of walk through the idea of power, and it kind of builds off of what a type 1 and a type 2 is. Type 1, type 2 error, type 2 and power really have a lot in common. So we're going to kind of talk about that idea. So here is our example. So Mr. Micah claimed he's an 80% free throw shooter. I believe that that's not true. I'm skeptical. I believe that he's less than an 80% free throw shooter. So Mr. Micah is going to take 50 free throws and he's going to try and prove himself. So in this case, again, the null hypothesis is Mr. Micah is in fact an 80% free throw shooter. Okay. The alternative is what I'm claiming. I'm claiming that he's less than 80. So this one is Mr. Micah is truthful. This one is Mr. Micah is exaggerating. Okay, so there's my null and my alternative. A type 2 error. So again, remember a type 2 error in this case is where we fail to reject the null when in fact we should have. So in other words, that's that thing where we find a guilty person innocent. So this one, what we did is we fail to reject the null when in fact the alternative is true. So in this case, what did we do? We went ahead and we said, Mr. Micah is an 80% free throw shooter. But he really isn't. Okay, so that is a type 2 error. Type 2 error is we failed to reject the null. On this one, we said he's an 80% free throw shooter, but he really isn't. He really is less than an 80% free throw shooter. So here's what we're going to do. We're going to go through and we're going to do this thing called power. So what I want to do is I want to kind of show you the situation here. So what I'm going to talk about here is, as we look at this kind of link, and this link is in our class file for today, you can kind of play with it. Up here it says, Mr. Mike is claiming he's an 80% free throw shooter. So if we look up here, 80% free throw shooter, we're going to try and prove less than, because that's what we're trying to do. We're trying to prove that he's actually a less than. Okay, now what I'm going to do is I'm going to say that he's really a 66% free throw shooter. So what I want to show you is this red curve right here. This red curve is what it would look like if Mr. Micah was actually an 80% free throw shooter. This is what 50 free throws should look like. The distribution of 53 free throws should be centered at 80%, and there's some variability there. What I want you to now look at is this blue one. This blue curve is what it would be if Mr. Micah was not, if he was actually a 66% free throw shooter. So this blue curve is actually centered at 66%. Now notice these curves overlap. Where they overlap is actually where we see our mistakes, our errors. So the first thing I want to show you is I want to show you what a type 1 error looks like. Type 1 error here, when I click it, what that is going to do is this right here is that area of 5%. So again, what I'm saying is my type 1 error is 5%. I'm setting it there at 5%. I'm saying that if I fall in that part of the red curve, so again, if Mr. Micah was really an 80% free throw shooter and I'm anywhere in this little area right here, this is where I have a potential of a type 1 error. What that means again is this. I am going to say that Mr. Micah is on the blue curve when he actually is on the red curve. He is actually an 80% free throw shooter. However, I'm going to conclude that he's not. That's a mistake. That's called a type 1 error. Okay, so that's my first one. Type 1 error is when I really should be on the red curve, but I say you're on the blue curve. Okay, so I'm going to turn that off. Now I'm going to look at a type 2 error. Type 2 error is where I'm going to draw the conclusion that he actually is an 80% free throw shooter when in fact he's not. And if we notice, what we're saying in this one is I am concluding that he's on this red curve, that he actually is. So type 2 error is I failed to reject the null. I basically said, hey, he's an 80% free throw shooter, when in actuality he's not. I said he was on the red curve. He should have been on the blue curve. This area right here is called my type 2 error. my type 2 errors, I say you're on more or less this red curve. So if we were to kind of draw a dotted line down here from this line right here, or draw a dotted line down here, we would say, we believe that we should be on this red curve here, but we're really on the blue curve. That's a type 2 error. Okay, so now if we actually go to look at this, when we go to figure out that area, it says up here what my probability of a type 2 error is. It says my probability of a type 2 error is 24%. So what it's saying is 24% of the time, I could actually say that he is an 80% free throw shooter, when in actuality, he's not really an 80% free throw shooter. That's called my type 2 error, the probability of that. The last definition we have is this idea of power. And watch what happens with power when I click power. Power is correctly rejecting the null. This is the probability of me saying to someone, you are not an 80% free throw shooter when you are not an 80% free throw shooter. I'm making the correct decision in rejecting the null hypothesis. That's called the power of the test. That's called the power of the test. So again, let me go back there so we kind of put them into its places. Okay, so if the alternative is true, if Mr. Mike is actually less than 80%, what is the probability of making a bad decision? So this is right here where I am saying that I'm going to conclude the null when I should not have. I'm going to say he's 80% when he's actually below 80%. That's my type 2 error. It often is represented with the letter B for beta. So that's my type 2 error. This guy right here is my power. My power is the probability of making a good decision. In this case, basically saying, Mr. Micah, you're not an 80% free throw shooter, you're less than 80%, and he actually is less than 80%. So the probability of making a decision here, what we're going to say is this. If Mr. Micah is actually a 66% free throw shooter, there is a 0.76 probability that we correctly decide he was exaggerating. So again, the power of the test is the probability of correctly rejecting the null. I know it sounds weird, but that's what it is, and it'll take a little practice to get a handle on this. So now, what I want you to do is I want to show you what happens and how we can play with the power of a test. So what I'm going to do, bring this back up. I'm going to turn off we're going to leave the power on. So there's the power. So if we look at this power, watch what happens if we want to go ahead and we want to increase the power. The first way we can increase the power is we can increase our sample size. So watch what happens now to this curve. When we increase the sample size, watch what happens to the power. So now let's say instead of Mr. Micah taking 50 free throws, he takes 150 free throws. We're going to go all the way up here. And there's 150 free throws. Take a look at what happened to the power. The power jumped up to 99%. The more he takes free throws, the more likely we are to see that he isn't an 80% free throw shooter. Again, if he takes 100 free throws and he's really a 66% free throw shooter, those free throws he makes are definitely going to be below 80%. So as we increase the sample size, what we can do is we can actually increase the power of the test. But notice what happened. My type 1 error stays the same. My power goes up, my type 2 goes down, and they actually go in opposite directions. As power goes up, the probability of making a type 2 error goes down. Okay, so that's the first one. So let's bring it back to 50. So we're bringing it back to 50, so where we started. So there's the first one. So now what's going to happen is the other thing I can do is I can play with my alpha level. So what I can do is I can say, hey, I'm going to increase the chances of making a type 1 error. So I'm going to jump from 5%, let's jump it up to 10%. Okay, watch what happens to the power. The power jumped from 76 to 84%. So if I basically reduce that number I'm looking for, increase that number I'm looking for is that significance level. If I say that, hey, 5% is no longer significant, 10% is now significant, something more common is now significant, what ends up happening there is I increase the power of my test as well. So alpha and power go in the same direction. Alpha and power go. So as you increase the alpha, you increase the power. Again, if you think about it in the context of the problem, it's kind of like the sense of this one is if I send more people to jail, I'm actually going to send more guilty people to jail. Like as if I just send more people to jail, the number of guilty people going to jail is going to go up proportionally. So that's what we talk about with our type 1 error, our alpha level. So we're going to drag back to 5. Okay. And the last thing I can do is I can play with the alternative. What happens with the alternative is the further the alternative is away. So in other words, the worst of a free throw shooter Mr. Micah actually is, the more powerful my test. So the further apart I make this blue and this red curve, in this case, it's going to increase the power. So let's just go ahead and let's say that Mr. Mike isn't a 66% free throw shooter. Let's say he is a 20% free throw shooter. Again, what this is saying right here is I have an incredibly powerful test. It's like 100%. Here's the reason why. If Mr. Mike is really a 20% free throw shooter, we should never see him shooting in the 80%. He should not. I mean, heck, if we make him a 40% free throw shooter, the power is still almost 100%. So if Mr. Micah is actually less than a 50% free throw shooter, if I move that alternative curve to the left, it actually does change the power. And what's going to happen there is, kind of to summarize it, is this. So when I deal with sample size, is the sample size increases, the power also increases. So now we're talking alpha level, significance level. As that increases, the power also increases. And I mean, conversely, as sample size goes down, power goes down. And then your alternative hypothesis, as that HA is farther away from H0, my power increases. So playing with that little app, hopefully it will allow you to understand it. And there's just one formula I want you to kind of keep in the back of your head. Power is equal to 1 minus beta, 1 minus my probability of making a type 2 error. So if I say 1 minus the probability of making a type 2, that's going to be my power. And oftentimes in the problem, you're going to be given the power and they're going to ask you to figure out the type 2 error, or they're going to give you the probability of making a type 2 and they're going to ask you to figure out the power. So it's different. I'll be honest with you, this stuff is different. This is a little bit more complicated, I understand, but just getting your head around type 1 and type 2 and power, it's important. Now, again, what I said in class was this: on this upcoming Unit 6 test, not going to really hit type 1, type 2, and power. I am in the next unit. So as we hit the means thing, when we do the same process for means, I'm going to focus a lot more on identifying type 1s and type 2s, identifying power in that sense. So hopefully that helps. Again, please remember to ask me questions if you got them. We are going to start our review next class on Wednesday. Our test is going to be on Monday the 7th. So thank you.